All right. So, hi, I'm Bob Lefferts. I work at a company out in Hillsboro called Synopsys. It's actually based in California. And we like to say that we do everything from silicon to software. Silicon being the material that all the chips that are made, they're in your pockets at the moment, or in your on your video games. And trying to make everything smart, everything. And one of the reasons that I'm here is that I like to spend some of my time making sure that not only is everything we build smart, but that we have smart people to build it. And so I'm going to talk a little bit about how I got to what I'm doing, but also make some comments about some things that you may not know because they don't really teach it in school. And I'll talk about that in a second. So what I'm going to do here is talk a little bit about what Synopsys does. What do we do? So Synopsys was originally created to sell software tools to companies that make chips. And the software that we sell helps them take the function that they want the chip to do and to actually place it on the chip and create the chip. We also make what's called IP, and IP stands for intellectual property. And what it is, you can think about it this way: it's a little tiny rectangle, about maybe that big, that you can drop on your chip that we've already built and already tested. And generally it's used to connect the chip to the outside world. So I know you've all know what a USB cable is because you've probably got 6 of them on your desk right now. And so one of the things that I worked on was the very first USB 3 when 2008, I think it was, anyway, where you would drop a little rectangle on your chip and you could connect it to the cable and have it talk to something on the other side. We also make software integrity tools to help people scan their software and look for security risks. We sell this software tools to lots of different companies, but a lot of banks use it to make sure that their software that they're using for their banks and their apps are secure, because nobody wants them stealing money. We also make emulators so that you can simulate the hardware before you build it. You may have heard this term, you probably haven't, but it's called digital twins. And so if you want to make something physical like a car or something, you first build a virtual version of it and then you can simulate it. So that's what the company does. It's a fairly big company, about 20,000 employees. And we make tools, we make little IP you can use, and we work on software, and we have hardware emulators. What did I study? I have a PhD in semiconductor device physics from Stanford University. What does that mean? That means that I went to school for a long time, about 5 years after 4 years of college, so 9 years from once I was in 12th grade. And I didn't plan on getting a PhD, but I stayed because I was learning a lot of stuff. I studied computers and the physics of solid, in this case silicon, that's used to make all the chips that are in your pocket. What do I work on? So I work in part of Synopsys that makes IP. It makes those little tiny rectangles. I worked in the integrated circuits when I was in college. And when I was in grad school, the smallest feature you could draw was a square that was 10 by 10 microns. How big is that? Well, a human hair is about 60 microns across. So when I was in school 40 years ago, the smallest feature you could draw was a square that was about 1/6 of a piece of hair wide in both dimensions. And it was 4 points. You could make a hole and you could cut a hole in a material that was 10 by 10 microns. Today, in my lifetime, we've gone from a single 4-point rectangle in 10 by 10 microns to, in that same 10 by 10 micron space, you can now draw 20 million shapes. So when I was in school, you could draw one, now you can draw 20 million. And so I've worked through that progression, and I'm going to go through some of the things that we've done in that timeline on the next slide. So I'm going to come to this it's a video here. I'm going to come to that in a minute, make sure that that's off, but I'll come back to that in a minute. So when I went to college, I decided I was going to study solid state physics, and that is the physics of solids. And in this case, it's the physics of crystalline solids. So what I'm showing you in the upper left-hand corner is the silicon lattice. I've colored the atoms red and blue because silicon is actually made of two interleaved face-centered cubic crystals. So if you look at the blue, there are a blue ball on all of the 8 corners of a cube, and there's a blue ball in the center of the 6 faces. So that's called a face-centered cubic lattice. And silicon is made up of 2 of those interleaved where they're shifted by a quarter of the diagonal down from the center. So that is what silicon looks like. In silicon, of course, they're not red and blue. They're all the same color. Now, that crystal means it's got crystalline properties, and you need to understand how to cut it and create it, because if you look in a certain direction, it looks like you can almost see through it. And if you rotate it a little bit, you can't see through it. And so they had to figure that out as they're manufacturing the wafers, to cut them at certain angles so that it looks more solid than porous. And it turns out what I'm showing you here is the location where the nucleus of the atom would be. So you can think about constructing a solid by placing atoms in a regular pattern and just keeping that going until you've got billions and billions of atoms. But you need to take care of the electrons. And it turns out, you've seen a model of an atom where there's a nucleus in the middle and there's electrons winging around the outside. Well, in silicon, you can model those electrons winging around the outside by taking 2 long balloons and twisting them together like you're going to make a balloon animal. And when you twist them together, you end up with this shape where the green balloon and the red balloon gives you 1, 2, 3, 4 points. And those 4 points are where the silicon nucleus would be. So if I add that to this drawing up here, I get this. I've got the nucleus of the atoms, the protons and neutrons in the middle, and then I've got the electron cloud that are connected between all the atoms by this 4-pointed balloon. Now, the thing that is absolutely amazing to me is that silicon doesn't look at all like this, and for one reason. The nucleus of a silicon atom is 1,000 times smaller than the electron cloud. So that if I were to take these blue and red balls and shrink them to the head of a pin, that's what it looks like. Most of all solids is empty space. The electron cloud around that holds everything together, right, is 1,000 times larger than the inside. And I'll have a link to a video. You can go see that for yourself. So what happens then is you can build, if you think about building a solid by placing nucleuses next to each other, right? Placing them down, then there's a place where the electrons can go. And it turns out if the nucleus, if the place that an electron can exist, if the number of protons in the center of the atom and the number of electrons in the outside exactly fill all the available states, you get what I call, this is my ping pong ball analogy of a solid. All the places you can get an electron are populated by an electron. So if you're thinking, if I took this as a bunch of ping pong balls in a cardboard box, when I tilt it, they can't move because there's no place for them to go. But if you have a different number of protons and neutrons in the middle, you might end up where there's 5 places for each electron to go, but the atom, the molecule only has 1 electron in that location. And so what you end up with is you end up with a bunch of electrons sitting in a box, if you will, that when you tilt it, they can move because there's other places for them to go. I'm sure you could name a couple of insulators, like things that don't conduct electricity, like glass or plastic, and metal, like copper or aluminum, will conduct electricity because the atoms can move. All of the electronics in your computer and your video games and your headphones, whatever, come from a material that at super, super cold is actually an insulator. And all the electrons fit in this a set of available states in the bottom. But what happens is at a little bit of temperature, the distance between where the electron could be and where it is when it's super cold, some of the electrons can have enough energy from bouncing around thermally that they can get up into the top band and move. That's what's called a semi-metal or a semiconductor. And so what happens is, if you look at the top, there's a bunch of electrons that can move up here, and down in the bottom, there's some missing places because the electrons moved up here, and the missing places are called holes. And so what we've done as engineers, we actually keep track of the electrons that are moving, and rather than keeping track of all of the moving electrons in the bottom location, we just keep track of the holes. And then a bunch of engineers figured out how to modify the properties of a semiconductor by adding material that's not silicon. For example, if you add boron, you end up getting more holes down at the bottom by capturing electrons in another state. If you add phosphorus, then the electrons end up in moving. And so you can create a transistor. And I'm showing you here a transistor that is quite a bit smaller than when I was in school, but there's an N region with electrons in it, another N region with electrons in it, and then there's a P region where there aren't any electrons on the top. There's just missing electrons at the bottom. And so you can apply a voltage and allow these electrons to move from one side to the other. But as they scaled this down and down and down, trying to make it smaller and smaller and smaller, the problem is that you lose control. The electrons tend to go around underneath the gate. You can imagine it this way. If I had a hose, pretty good size hose, and I wanted to stop the flow of water by just pushing on the top, well, you got to push awfully hard to keep the water from moving at the bottom of the pipe, right? So what they've done, and this was invented actually at Intel, is that the way that they do it is that they take this transistor, which has a gate, which is where the voltage applies. It's got metal contacts on either side, and the current is flowing from one side to the other, depending on the voltage on the gate. And so what they've done is they have taken the gate and they've sort of taken this piece of silicon and they've pulled it up like you're making a piece of corrugated cardboard. And they keep pulling it up and up and up so that the same size of the device, but it's been squished in the one dimension, and now it's in 3 dimensions. It's sticking up in these fins. And this is what's called a FinFET. And then you take this FinFET, and to scale it down, you put some contacts on it, and then you take the gate and you make the gate, the actuals, much, much smaller until it goes down to from 28 nanometers to 5 nanometers. And so there is a FinFET. And the silicon, I'm going to stop this. Let me go back here a second. So what happens is the current still flowing from left to right, and it's gated by the gate. That's why they call it a gate. So you can imagine if I had a pipe of water and I put something all the way around like a pipe clamp, and I squeeze it from all sides, then I can turn it off. And so what happens is that these transistors turn off. This is the current they're carrying versus the voltage on the gate. And you try to turn it off, a classic device leaks a lot, whereas this device with a FinFET is much cleaner. And the problem is with a computer is that not everything's on at the same time. And so you want to be able to have devices that are sitting there off, that there's so many of them that the part doesn't melt. So if I then look at an actual device, here's my picture of what it looks like schematically with a gate over the top. And if I go through the look down this yellow line, it's shown over here. And these are those fins. They're actually really, really tall. Looks like a carrot, but they only use the top of them for carrying current. And in this case, the current would be flowing in and out of the page. And that thing wrapped around the outside is what's essentially trying to turn it on or off. Now, the amazing thing is that if you zoom in on the end of this device, you can see the gate oxide is very thin. It's this very thin material here. But if you count, each one of those little bumps is actually an atom. There's only 40 atoms across the silicon fin that's making up this device. And so the current flows in and out of the page, right, this way, and is gated by the gate. And then they take all those devices at the bottom and they add all this metal layer on top. And they stack all these metal layers up to connect everything together to make computers and make things that can do displays, that can add, that can connect to the internet, and all that stuff is built out of these transistors. So when I was in school, they were pretty big, like 10,000 times bigger. Now there's 20 million transistors where we could draw a part of one. And so that's what I worked on for the last 40 years or so. And I'm going to pause for a moment and take some questions if you have any. Anyone have a question? All right. I will move on. So now I'm going to give you some advice, some grandfatherly advice. A bunch of years ago, I went to a university and I was going to be recruiting people the next morning. And the night before, I gave a talk about what my company did. And first thing I did is I went around the room and I did what I did here. I said, how, well, actually asked for your name and what degree you're getting. It was equivalent to asking what year you are, but what degree you're getting. There were about 40 people in the room, and I went around the room and everyone was getting a master's degree or a PhD, master's, PhD, master's, PhD. One kid in the back said bachelor's degree. So that's a 4-year degree. Master's is like a 5 or 6 year degree, and PhD could be 5 to 9 years post high school, right? And then it went around farther, master's, PhD, master's, PhD, master's. So I did my little speech. And at the end, when I was cleaning up and everything, the kid came up to me that was getting his bachelor's degree. He was rather intimidated, right? Like a freshman versus a senior. He said, I'm just getting my bachelor's degree. What do you expect me to know? And I said, that's an interesting question, because clearly he was a little bit intimidated by the fact that all these people around him had been in school a lot longer than he had. And I said, well, let me ask you a question. If you went to a doctor and walked in his office and he looked at you and he said, I know what the problem is, what would you do? I would run. How could he possibly know? I haven't told him why I came to see him, right? So I said, I'm not hiring you to solve a problem you know how to solve. I'm hiring you to solve a problem I don't know how to solve. And I've been doing this a lot longer than you are. So I don't expect you to know the answer to anything I ask you. But like the doctor, I expect you to have a little black bag with stuff in it you know how to use, and other equipment where you can take other data, so you can then take some data to figure out what the answer is, because neither of us know what it is up front, right? So I told the kid, I said, look, I expect you to show up with a black bag with something in it. What's in your black bag? And he said, well, I'm good at math and I'm this and stuff, but I don't know a lot, but I know how to do some stuff. And I'm saying, great. The next day during the interviewing process, I hired the kid getting a bachelor's degree. I didn't hire any of the master's students or any of the PhD students. And I'll tell you why. When I asked a PhD student a question that he didn't know the answer to, he would try to impress me with the information he did know. But when he didn't know the answer, he couldn't do anything. And this kid getting his bachelor's degree walks in, I gave him a problem that made no sense. He goes, you know what? I have no idea. That doesn't make any sense, but I do know this. So what would happen if you did that? And it was, I told him, he goes, oh, well, then what would happen if you did that? And then what you did? And he figured out the answer. He wasn't afraid of what he didn't know. And I cannot stress this enough. Never be afraid of what you don't know. Never be afraid of what you don't know. It's just an opportunity to learn something if you don't know it, right? So keep that in mind. One thing people, when if you're headed off to college, remember, when you're done with college and someone says, hey, kid, what's in your black bag? Please don't say, I can't think of anything. I interviewed a kid in Hillsboro. He just graduated from Oregon State. And I said, what's in your black bag? And he said, I can't think of anything. And I said, don't tell your parents. You might want to get a job in marketing, right? Because you took an opportunity in college to fill up your little black bag with stuff you do know, so you can figure out things you don't. And you miss that opportunity. So never be afraid of what you don't know. Treat it like, in fact, in an interview, when someone says, hey, do you know anything about this? I say, I know nothing about that, but I know about this and I know about that. Is it similar? Right? Can I learn? I will hire anyone that can learn. I'm not hiring you for what you know necessarily, because if you can't grow what you know, you're obsolete the first day, right? Now, I tell high school kids at every opportunity I can, don't have an interest. I've seen resumes where it says interests, and it says, I'm interested in football. I'm interested in video games. I'm interested in whatever, soccer. I'm not interested in your interest unless you're interested enough to do something with it. So if you have an interest, try to do something with it. Now, I had two teenage boys at one point in my life. They're older now, and an older daughter. And we had a deal with my boys that for every hour they spent playing a video game, they had to spend an hour making a video game. Okay. Now, my son learned to draw pretty well on the computer, because that's what they were doing. They're making their video game. They were drawing, this is many years ago. And So when he went off to college, he tested the theory in high school that they wouldn't flunk a senior. I don't recommend that to you guys because he almost proved himself wrong. The other thing which he discovered after the fact, which was more hurt me more than him, is that he missed the GPA, the grade point average cutoff, to be able to pay in-state tuition out of state in Idaho by 0.01 for his grade average. One homework assignment would have cut his cost in college in half. So when you don't think it matters, I'm telling you it matters, right? Anyway, so he went off to college and he took an art class because it was a prerequisite for the architecture school. He calls me up halfway through his first semester. He says, Dad, I got my sketchbook back in my art class. I said, great. How'd you do? He said, I got an F. I said, why'd you get an F? He said, I have no idea. I said, you know, I write a big check to them every year. You're allowed to go talk to the professor. Go ask her why. So he went to the professor and asked, I got my sketchbook back. I see you gave me an F. Would you mind telling me why? The professor said, it's a sketchbook. All you did was cut out clip art from the internet. He goes, that's not clip art. I drew all that. She goes, what? And he opened up his laptop and everything in his sketchbook, he'd drawn on the computer, printed it out, cut it out with a pair of scissors and pasted it in the book. She goes, oh my, are you using like Photoshop or Corel Draw? And he goes, no, I just used the drawing tool in Microsoft Word. That little rubber band thing I'm sure you guys have all seen. That's what he was drawing with. And she said, you need to go talk to this guy over here. He runs the animation department for the architecture school. And my son, 4 years later, graduated with a degree in animation. And he graduated in 2008. There were no jobs, a big problem in the economy. But anyway, 8 years after he graduated, he got an Emmy. He is now works at a video game company. He worked on animations and CGI for every TV show you can imagine, Agents of S.H.I.E.L.D., all kinds of stuff. He won an Emmy for a shot he did for American Horror Story, but all because he had an interest, right, playing video games, and he learned how to do something with it. He learned how to draw, and he then used that. He now literally is a character artist on a major television show. He has a advanced Sony PlayStation that's bolted to his desk in his house because it hasn't been released yet, that he gets to do all of his animations on for the next game. That's pretty sweet. So if you have an interest, do something with it. Learn to make your own video game. The work that my son did when he was little was many years ago. The software doesn't even exist that he was using. But my grandson and I made a video game. And so I have a YouTube channel where if you want to learn how to make your own video game, you can go to youtube.com/@DrBobble. And there's about 10 episodes in there that'll show you how to program in Python and make your own video game. If you're interested in video games, you might want to figure out how to make one. So that's my recommendation. At some point, you guys are kids still, right? You're in high school. You got other problems to figure out than college or whatever. At some point, you have to figure out how to apply to college. So again, if you have an interest, do something with it. That's something you can put on your resume. College is where you figure out what you're passionate about, because they have all these opportunities to take classes, do whatever, go to lectures and find out what you're interested in. And that's important. My youngest son was passionate about ice hockey. He wanted to play ice hockey. He ended up going to college on the East Coast because they had better hockey on the East Coast than the West Coast. And he got cut from the team. And he was devastated, absolutely devastated. Told me, it's a good school. Find something that interests you. So he became the president of the comedy club. He graduated as the president of the comedy club. There's a YouTube video about his horrible childhood. But what he started getting interested in was exercise science, where they were using the hockey players as guinea pigs in the lab. And he spent time in the lab running on a treadmill with 60 pounds of firefighter gear, studying heat exhaustion, and has gone to Mount Everest. When he graduated, he went to Mount Everest, not to base camp, with 20 undergrads studying altitude sickness. He's actually going again this May. He's a college professor in Iowa in exercise science. That's what he turned out to be passionate about. He was big in exercising and played hockey. Now he studies exercise. So find what your passion is. It's very important. I don't believe you should be able to graduate from high school without seeing the last lecture. The last lecture is on YouTube. If you just type in the last lecture, it's a lecture given by Randy Pausch, who was a professor at Carnegie Mellon. And he created a lecture series called The Last Lecture. And he invited professors from other universities to come, and they said, if you had one last lecture to give, what would you talk about? And so that's what the titles of this lectures were. And then Randy Pausch found out that he had stage 5 liver cancer and he had 4 months to live. And this video is his last lecture, and it is unbelievably good. It is really, really good. You shouldn't be able to graduate from high school without watching it. So I highly recommend that you go see the last lecture by Randy Pausch. It's about an hour long. He was one of the guys leading in a lot of the AI, what's it called? The vision, the 3D vision, the not artificial intelligence, forgetting what it's called.
Virtual reality.
There you go. Virtual reality. That's what it is. So he was one of the leaders in virtual reality and taught a bunch of college courses for kids to learn how to make virtual reality stuff. So I highly recommend that. The other thing is, there is a video on YouTube. If you search for Powers of 10, this is a video that was made in 1977 when the computers, the fastest computer in the world was slower and a lot less capable than your cell phone. And it shows you how much of the universe is less empty space. It starts off on a picnic blanket in Chicago and zooms out to the edge of the universe, 10x every 10 seconds. And then it goes backwards and goes into the guy's hand and goes all the way down inside of an atom. And it is, my granddaughter fell in love with galaxies by watching this video. It will give you an appreciation for how much of everything you know and love and feel is just empty space. When you bang your hand on the desk, there's nothing but empty space. It still feels solid, but it's all empty space down inside. And once you get outside the earth, it's all empty space and space as well. It's pretty amazing. I highly recommend it. So I have some time left to take any questions from anyone that has a question. And if I don't get questions, I can fix that problem by asking you guys some questions.
Oh, yeah, I have a question.
Yeah, go ahead.
So you said Synopsys is in cybersecurity, right? And like software?
We do software security, correct?
Yeah, so is that something like McAfee or like a antivirus or something like that? Or something?
Great question. Excellent question. No, it's not. So McAfee is more of the software that is trying to act as a barrier to the data going in and out of your computer, right? It's trying to keep the bad guys out, basically. What we do is called software integrity. So what it does is it scans your applications, your apps, or your web pages and looks for vulnerabilities in the software you write so that people can't get in and get inside the operating system. So it's a little bit different. It's not a hardware kind of thing, or it's not running on your hardware per se. It's something that you scan your software before you release it. So it's called software integrity as opposed to data security, right?
Yeah, that makes sense. Thank you.
So yeah, so it's a little bit more like, for example, if you're writing code for a bank, for their banking app or whatever, you could run it through our software and say that right here in the code, the way you wrote this could be, someone could get into the code and do something that you want them to do. You need to change it this way, or things like that. It's sort of a, it gives you a quality score on how clean your software is, as opposed to a McAfee thing, wherever that's looking at the traffic that's coming in and looking for things that shouldn't be there, or looking at software processes that are running on your computer that look like they're malware.
Yeah,
Good
that
question.
makes sense. So it's like it scans software for vulnerabilities, right?
Correct.
Basically.
That's what it does.
Yeah.
That's exactly what it does.
Thank you.
And we also work with a lot of foundry data from all the different manufacturers in the world where you can get silicon from, right? So there's Samsung, TSMC in Taiwan, and Intel. And so we have a lot of things in our company to protect that information so it can't leave the building. because it's very, very proprietary information on how they're building all this stuff. And we need access to some of the information in order to design chips on it, but we don't want that to be leaked from one foundry to another or whatever. So we do a lot of security work in the company to keep things isolated and contained. Any other questions? Anybody on the call like a video game? Anybody want to admit to playing a video game? Is there anyone on the call that doesn't play video games? No video games? Board games, maybe?
Board games. All
Board
day
games.
long.
Board games and card games. I like board games and card games as well.
We do have a couple questions in the chat.
Oh,
One
perfect.
from Sapa says, how does a typical day in the type of job look like? And then what kind of education do I need to acquire?
Okay. So here's the thing. So typical day depends. So a good day for me is when I learn something. And when I learn something is when something goes wrong and I don't know why it's broken, right? Something happens that doesn't work and I have to go figure out why. For me, a bad day is when I don't, I was a bad day, but a boring day is one where nothing goes wrong and everything just goes smoothly and I don't have to do much, right? I like to make things. I write a lot of software. I like to make things that didn't exist before and solve problems that way. I'm big on problem solving. So for me, typical day, it depends on what I'm working on. But a lot of times I'll get an email or something, or there's a problem that needs to be looked at. This doesn't work, and go figure out why and go fix it. There's other times when getting together review work that's been done by other people. I'm working on some things right now where I'm reviewing some ideas that people have for making new products. I am working from home at the moment, and so I do everything on Zoom and Microsoft Teams. I would say that generally half my time would be doing data analysis and analyzing data using different tools or writing tools to do that. And obviously there's time spent in meetings, but I helped build our infrastructure. So I get a lot of questions on how does this work or how does that work over the time. So for me, I'm at a point where I'm thinking about retiring. I've been doing this for a long time. And so I'm getting a little bit less out of the day-to-day operational work and more into building some things that we need in the future that we aren't currently using. So I would say that most of my expertise is in the knowledge that I have about how we're building the IP that we're building, the software skills that I have to solve problems, and general problem solving, I would say. So it didn't always start out that way. When I was a lot younger, of course, it was a lot more doing a specific thing or making something happen. And I've worked on lots of different technologies, which is great. So I have a lot of experience doing that. So what do you need to get, let's say you want to get a job building something that you can carry around in your pocket. What do you need to do, right? Well, the first thing that is important is that it's very important for you to take the opportunity that you have to learn how to learn. It's not so much that you know, someone's going to ask you, do you know how to measure the area of a triangle? And I'd like you to measure the area of a triangle. I've got a room full of triangles. That would be a pretty boring job, right? It's much better to somebody say, hey, I'm going to build a robot to go in that room and measure all the triangles. Would you like to be the guy measuring the triangles while we build a robot, or you want to be the one building the robot? I don't know how to build a robot, but I don't take the job where I know how to measure a triangle. No. Don't take the job you don't know how to do, because that means you're going to learn something, right? So one thing that's important is to learn how you learn. And I love analogies. I find analogies extremely helpful to explain things to other people as well as to understand them yourself. So I would encourage you to you know, ask, does that mean it's like this, or like, how's it different from this, or how's it different from that? I was told something when I was a grad student, that Einstein invented or came up with the theory of relativity by imagining what it was like to be an electron. And so I found that very helpful to use my imagination to say, well, how could this work? Is that possible? Is this not possible? Right. And so the one thing that's important is to figure out what you're interested in, to be able to have some tools in the black bag. Math is great. Math is wonderful, right? Because you can use it to solve anything pretty much. Being able to program is great. I program a lot, but I'm not a programmer. They're not paying me to program. Some people do, they become programmers, and that's great. So it depends on what you like to do. And what to figure out what you like to do is by doing a lot of different stuff. So science is good, math is good, physics is good. Being curious is super good. And the other thing is, when you look at the last lecture, you'll find that there's a brick wall. He talks about a brick wall. A brick wall is there to keep everyone else out. Your job is to find a way around it if you're passionate enough about doing it. And he gives a bunch of examples. So for example, I had a kid that was in school, and it was a terrible time in the economy, and he couldn't get a summer job. And he came and said, hey, can I volunteer and work for you for the summer? Because I know you can't pay me. And I'm like, I don't know if I can do that. And I went and I checked with the human resources, and they're like, no, you can't just take a kid off the street. And I told the kid, I said, I'm sorry, but I can't not pay you and have you just show up. And instead of saying, oh, bummer, and going back to doing whatever he was doing, he picked the phone and called one of his professors at the university that he was going to. He was a junior, I think. And he said, hey, if I write up what I do working for Synopsys for the summer, will you give me 1 credit? And the professor said, sure. So he called me back and he said, hey, I can get a credit if you let me work there for the summer. And I would talk to HR. They go, well, then he's an intern. That's not like some kid walking off the street and just sitting there. He's actually doing it for school. So yes, you can bring him in and not pay him. And so that's what we did. We brought him in for the summer, gave him something that we weren't going to ever get to at the rate we're going, and he worked on it. Then he graduated. We didn't finish what he'd started, so we hired him back to finish what he started. And with those 2 things on his resume, he got hired by another company in town. And a year later, we hired him back. And he's been there now for a handful of years, but it was because he didn't give up. So I told a high school student a while ago that said, I'm super passionate. I want to work in a lab. And I said, great, go to a lab, find a lab in Portland and go volunteer there. I said, well, can I do that? Yeah, you can do that. And if they tell you don't, ask them why and figure out a way around it. So that's what I would recommend, is that to separate yourself from the rest of the pack is having something you have enough interest in on your resume to say you did something with it is super helpful. My youngest got into a very good school on the East Coast because when he was in high school, he got interested in building a animated version of Beowulf that they were studying in literature or whatever. And he did a whole thing, including the voiceovers and everything, and made a little animation that he actually submitted on a CD to the university he was applying to. And they're like, okay, this kid at least with about 100,000 mouse clicks to build this thing. He did something, right? He did something. And that's what's important. Go do something. The other thing which is important is, if you can find some way to get paid to do something, then it's not about the money, it's about the references, right? They have somebody you can talk to and say, hey, this kid works hard. He showed up on time, right? He's interested and whatever. That's what I would encourage as well. What else? Do we have another question? What types of coding programming language is important? Oh, Java, Ruby, Python. So I learned Python when I made the video game that's on that YouTube link. I hadn't programmed in Python before. It's a great language, and I really like the stuff that helps you. The YouTube video shows you how to download PyCharm, which is essentially an environment for developing Python. It's great. It's a little tricky to answer that question because of some of the things that are in the news with ChatGPT and some other things that will write software for you. But Python's not a bad choice. Definitely not a bad choice. And the main thing is getting your mind around how things work and how you can write code and how you can reuse code. And that's one of the things I covered in my YouTube video is the whole object-oriented programming and how to make an object and how it works and that kind of stuff. So it doesn't really matter which you choose as long as it's helpful to be able to be flexible but Python's a good choice. Python's an excellent choice. Any other questions?
We do a couple more. Is the software protection in most of technology we see now?
Is the software protection most of the technology we see now? So it depends. The software protection where you're scanning people or scanning their software to make sure that it doesn't have vulnerabilities. Yes, that stuff's been in place. We've been selling that stuff for 5 or 6 years now, and it's being used quite heavily. A lot of the super secure stuff that's coming because all the stuff's going in cars and everything. Nobody wants to be a hack into a car. That stuff is in process, right? It's happening now. A lot of that is some of the security products that we sell to go on your chip to make it secure. I think that in general, what you're seeing as everything becomes smart is it needs to be not only smart, but secure. And otherwise it's not so smart when someone else takes over, like the guy who hacked into a car and whatever, and was driving it remotely. That's not a good thing. So yeah, all the security stuff is coming. And so again, a lot of math and security, a lot of signal processing, is useful. What else? What other questions?
I have a question. So, how do you get an internship in high school? It doesn't have to be paid. I just want to get some experience on my resume.
Sure. So, it's a great question. So, most of the internships are a lot of the internships are in college, right? The biggest year is junior year in college to get something meaningful that you can do from an internship. That's the big one. But I've hired interns that are freshmen because they were super smart and totally fearless. I hired an intern once. He showed up and I handed him a stack of manuals that big on the first day. I said, read these, and when you're ready, let me know. And he came back the next day, he said, let's go. And we did. And the kid, man, was he smart. So there were people that I worked with I'd been working with for years that would say, hey, it's 4 o'clock in the afternoon, time for me to go watch Jared. And they go in the lab and they'd watch this kid because he was so fast on the computer, his fingers were flying, that everyone was watching him. He is now a professor at Princeton. And so that's great. He told me that the thing that surprised him the most being at a small startup that he was at when I hired him was that he'd never been around a group of people that were committed to doing something, but they didn't know how to do it yet. Because that's what a startup is by definition. They're trying to build something that hadn't been built yet. And now he is the world-renowned expert on optogenetics, where they modify the DNA of some biology and then shine light on it so the DNA becomes sensitive to light, and they can turn things on and off in a cell, which is otherwise very difficult to do. So if you're in high school, it's not so much as an intern, because to be honest, most high school resumes are kind of empty, right? It's more of, what can you do to put on your resume that you did, right? I just saw a resume of a high school student the other day that was given a pair of 3D goggles, whatever those things are called, and some micro manipulators, and built in high school, built a way to remote for a eye doctor to remotely do eye surgery. That's what he did in high school. Pretty freaking impressive. I wouldn't expect that normally, right? He's now in college. But do something, right? When you're in high school, do something. And the other thing is that if you like to program and you want to build stuff, go buy an Arduino card off the internet and just make something, build something. Yeah, just kind of, yeah, if you're playing video games, great, make a video game. How do I do that? Well, there's ways. There's the link right here. Anyway, so getting an internship in high school, right, to add on your resume for going to college, it doesn't have to be in the area. I don't expect anybody in high school to know what they want to work on. My son almost didn't want to go to college. I mean, he didn't know what he was going to, he had no idea what he wanted to work on. The one that's got an Emmy for doing animations, he had no idea. I don't expect anybody to know what they want to do. Some people do when they go off to college. Some people don't. But the idea with something on your resume is that I'm in high school, I've learned all these things, I've got decent grades. That helps because it learns that you know how to do what you're told, so to speak, right? To get something on the resume to separate you is it where do you spend your time when you're not in school, right? Sports is great. excellent to have on there. Getting a job is great. Doesn't matter what it is. There's somebody that can say this kid shows up on time. He's bright. That's it. Because otherwise you're only looking at a piece of paper that's got white space in it, right? And a couple of words. Very difficult to hire out of high school. It's still difficult out of college because they haven't necessarily done anything, but that's where an internship really helps. But like I said, if you're, let me ask a question. That was Alan that asked the question, right?
Yeah.
So Alan, let me ask you a question. What are you interested in right now? If you had a magic wand, what would you be doing for the summer this summer?
This summer I'd probably be like building website or programming, and I also have an Arduino set, so I would maybe like make a robotics program or something like that.
Okay, good. Well, so if you're interested in the software, you're interested in Arduino, that's excellent. Doing something with that, building it yourself, that's great. You can do a lot of stuff on YouTube, right? The kid that built this thing where you could do surgery basically just looked at YouTube videos on how to make things work. So I think that's all that's necessary. What grade are you in?
9th grade.
9th grade. So you got all the time in the world to just spending time like getting on an Arduino board, all that stuff, doing some software programming. That's all excellent because the way you learn is by failing, right? To get something to work, you got to fail a bunch of times, and getting used to failing and getting used to trying this and trying that. Excellent. Having an interest and just sitting there with an interest, not doing anything with it, not so exciting.
Yeah. Thank you.
Yep. But yeah, so anything you can do. I interviewed a kid recently in high school that we got to talking. I had his resume and he had his classes in there that he took. I mean, there's really nothing on his resume. And I said, well, what do you do for fun? He goes, well, I make virtual scenery with their software. You can basically build digital scenery. And I've been selling it to somebody. I'm like, dude, why isn't it on your resume? I'm interviewing for a job in a food store. Why would it? No, dude, put it on the resume because that shows you did something, right? And someone's paying you money. That's huge. Nobody paid me money in high school. Anyway, but excellent question. So think about what you want to do and then say, hey, I like to do this. You can go volunteer with this. What do you mean volunteer? Yeah, I'm going to volunteer and help them fix their computers. Great. That's great. Something that is better than waiting for it to land in your lap. Be tenacious. Any other questions?
Yeah, I have a question.
Yeah.
I'm just wondering, like what your work-life balance is, like how stressful is your job? Do you get to travel or not, or things like that?
Question. Excellent question. So I have done a reasonable amount of traveling in my career. I worked for a company, I did a lot of traveling to Japan. I worked for a company where I went to Taiwan a few times, and I now work at Synopsys. I've gone to Armenia, which is literally on the opposite side of the planet. Many times I've been to Armenia, I've been to Poland, I've been to Portugal, I've been to I haven't been to India yet, but I've done quite a bit of traveling. I had a team of about 150 people. Most of them were spread around the globe. There's only like 3 or 4 in my office. I work post-COVID. It's a long day for me. I start around 7 o'clock in the morning and finish at 5 o'clock in the afternoon. But I don't do weekends in general. A couple times when I get excited in something. One of the things I'll get involved in something that I like to do, and then of course I'll end up spending some extra time in it, but it's not too bad. There are some companies that tend to, like my son was offered a job, but they said he had to work 7 days a week and he had kids. He's like, that's not going to happen. And so he ended up changing careers, got into video games instead of doing animation for TV. So I haven't been in that situation. I actually worked at a startup company once where they typically work really long, crazy hours. And I went in saying, look, I've got kids in high school. I'm not working weekends. I'm just working during the day. And I was unprepared for how much I could get done in a day without anyone in the building to interrupt me. And so there was no way I could have worked more than the hours I worked during the days, because it was so productive and I was so worn out by the end of it. So as my son said, I like to play hard, I like to work hard. So I would say my work-life balance is pretty decent. My wife probably disagrees, thinks I work too much. I'm now down to 4 days a week. I'm only working 4 days a week, which is great. But of course, I'm an old geezer, so that's okay. But in general, the main thing is if you follow the fun, the money will come. And at least that way you're doing something you enjoy, right? If you go after, I once talked to a high school kid and I went around the circle, there's 6 kids around. And I said, so what are you interested in? And the guy, and basically he said, I want to be a billionaire. I said, great. Doing what? He says, I don't care. You just want the money. And I'm like, okay, but that first of all, you better play the lottery a lot because that's the only way to get it if you're not interested in something. And then what do you do with all that money? If nothing interests you, what the hell? You know, you buy a little bit of everything or a lot of everything and you're done, right? So, and a lot of companies are pretty careful about work-life balance these days, but the main thing is if you enjoy what you're doing, then it works. But it's an excellent question. So for me right now, work-life balance, I think is awesome because I'm only working 4 days a week and I'm working from home. So I don't have to go travel anywhere. I don't have to commute. Any other questions?
Knowing what you know now,
Yes.
and kind of sticking in a similar career field for the longevity of your career, what would you go back and tell your younger self?
What would I go tell my younger self? I guess. Okay. Well, here's the interesting thing. What I would tell my younger self is that, yeah, I thought of something which I read somewhere that somebody said, when someone asked that question, go back and tell your 10-year-old self, what would you tell them? And the answer was stretch, dude, stretch. Because when you get my age, you should have been stretching for years. So I thought that was pretty funny. The other thing, which I also heard somebody say, which definitely rung a bell with me was, hey, dude, shut up. Nobody cares. Just shut up and listen. And I think what I would tell my younger self is that, think about the following. When you get older, your favorite choice is to do nothing. My favorite choice is to choose to do nothing. I don't have to decide or do anything today. I can push that off to tomorrow. I don't have to, this will resolve itself if I do nothing. Because when I was younger, I ran around a little bit like the sky was falling and I was trying to fix everything in place, right? And a lot of that was two things. One, remember, someday you're going to think that doing nothing is a good thing, as opposed to trying to make your own chaos, which I used to do as a kid. And the second thing is that just relax. It's all going to work out, right? It's all going to work out. When it doesn't work out is the stuff that you don't worry about, right? I once had a college professor that had retired said, he said, well, how is this all going to work? How are we going to do all this stuff? And basically the answer was, if you're worried about it, I'm not worried about it. It's the stuff you don't worry about that can end up biting you because you're not even thinking about it, right? And it can just happen, right? So I think the advice to my younger self would be, take a breath, right? Doing nothing is actually getting good at doing nothing and doing less. I used to do a lot of work for the people around me. I was like, how do I do this? Oh, let me show you. And I'll do it for them. And then they come back a couple months later. Hey, that thing you showed me how to do? I forgot it. Could you do it again? So I'll do it again. Instead of saying, dude, here's how you do it. Go do it yourself, right? That was a character flaw of mine. Try to fix everything. So one thing I would say, if there's anything to take away from this, anything at all, you guys need to practice being aware of when you don't know something. When something is introduced in class, you go, I have no idea what they're talking about. That should perk your ears up like you were a cat and go, whoop, I don't know what's going on. Pay attention, because that means I can learn something. And the next time I will already have learned that and I won't feel like I don't know it. And never be afraid of what you don't know. Anytime you don't know something, it's an opportunity to learn. One thing I will tell you is I got 2 minutes. When I was trying to get into the PhD program at Stanford, they get into the program, it was 10-minute oral exams with 10 different professors. They had 10 minutes. That's all. And what would happen is you walk into the room and they'd ask a question. And if you opened your mouth and started to make anything that came out that even remotely resembled that you knew what you were talking about, they would stop you. And they'd ask another question. And as soon as you started, well, that's what they'd stop you and they'd ask another question. And when they ask the question where you go, could you say that again? That's the question they give you, the one we have no idea what to do, because they didn't care about what you knew. They cared about what do you do when you don't know? And so keep that in mind, that when you don't know something in school, what do? Do you just don't deal with it? Or you say, I'm going to figure this out. I'm going to ask somebody. I'm going to ask a person next to me. I'm going to figure this out because I don't understand it. That would be my advice. Never be afraid of what you don't know and pay attention when you don't know something. I hope that was helpful.
I know it was for me. Thank you.
Not a problem. And for all the people that showed up, dude, there's a lot of people that didn't show up. You guys showed up. I hope it was worth your while. My email is bob.l@synopsys.com. When you want your software gig, when you want to, once you get through college, you want to work someplace and they're writing software, send me an email. Send me an email.
Any other last questions? Now is your chance.
I have a question.
Yeah.
One more question. So what do you think is more important for a computer to work well, software or hardware?
Well, so here's the thing. Here's what I'll say. What we're finding and what everyone's finding is that it's not an addition problem, it's a multiplication problem. So if you said that the software was giving me 3 and the hardware is giving me 0, you still get 0, right? And what we're finding is that they need to play well together. And one of the things that you'll see as you get into doing software is that there are a lot more people using GPUs, which are actually not computers. They're hardware for the basic video processing machines that can be used to run your software. And they run 10 times faster than a computer, because the way a computer works is it's a lot of little tiny steps around over and over and over again. And so what you'll find is it's the combination of both that matters. The software and the hardware need to be balanced. And so my answer is yes, both.
Both. Okay. So both need to be there for it to work properly. Yeah.
To be optimal, correct. So for example, you could have the world's smartest computer, the world's most crazy computer. It could do anything in the world without a keyboard, and without a mouse, and without a screen. It's got nothing. It's not doing anything, right? But you can also write some amazing software that's just so slow it doesn't really do what it's supposed to do, right?
Yeah.
It is amazing to me, to be honest, with object-oriented programming, how a single human like yourself, Alan, could sit down and write a program that takes more memory than the computer had on disk when I was your age. So when I got a computer, my first computer, I mean, it was like 40 megabyte hard drive was gimongai. You can't do anything in 40 megabytes today, right? You've got 256 gig in your phone, probably. Well, probably not that big, but anyway. So it is amazing how much software a human can write, because of the higher level languages just take a lot of memory.
Yeah. Thank you.
Thank you.
All right.
There one last opportunity. Speak now or forever hold your peace. Just kidding. If you have more questions and you ever are curious, we are more than happy to connect you with Bob. But thank you, Bob, for taking your time out of your day again
No
to
problem.
come and speak to our students. Students, thank you for engaging. Thank you for asking questions and participating with us today. Again, if there's anything that you learned from today, go share it with your friends. Tell them, and make sure your friends come to events like this, right? Again, we set these up for you guys. So we want to have as many of you as we possibly can. Tell them why they should have been here, what they missed out on. Again, if there's additional careers that you guys are interested in, that you want to learn more about, let us know so that we can create more events for you. Which does bring me to, Bob, if you wouldn't mind stopping sharing your screen.
Yeah,
I just
yeah,
want to
yeah.
show you students. We have 2 upcoming events that I want to show you